there are two big problems. First, oxytocin is a very friendly hormone and it sticks to just about everything. It's actually, because of its structure, its stickiness, its ability to touch and hang on to other molecules, that it's so powerful. But it means that it's hiding in plain sight. It's very difficult to measure oxytocin. Many laboratories just give up because it's so much trouble. They have to worry about how the samples are handled if they're using blood, or we invented a salivary assay so we could measure it non-invasively. But it changes. It has two ways you could look at it. One, it seems to predict how the body will react, especially when there's a stressor. So a lot of the time, oxytocin's sort of hanging out in the background, not doing much. But when we need it, let's say you've had an intensive period of exercise, a clear stressor, or you've had a psychological stress. It's then that we are most able, in a scientific sense, to see what oxytocin's doing. And that, of course, we didn't know in the beginning. It was just like, oh, we'll measure it. Okay, should be easy. Well, it's not. It's a real pain in the neck. Oxytocin very conveniently buffers the human body against stress. It does it, again, very quietly. So if you're injected with oxytocin, if you don't have a tissue that's been primed, for example, the uterus is primed to respond to oxytocin. If you don't have that tissue, you won't actually know that you've gotten it. There have been a lot of studies where it's been given, and they carefully created a placebo, a matching carrier, and people couldn't tell unless they had a primed tissue. And they can't even tell when they're stressed because their body doesn't have a real clear signal exactly for what the word stress is a terrible word because it makes it sound like we actually know what that is. But these are big concepts. We know they're important. We just don't know what exactly we mean. All we can know is if we're able to change our response. And when oxytocin's present, we're much better able to manage stress. It's actually a surrogate, a kind of message that equates to having safety or a safe other with you. We're incredibly social species. We can't be put alone in a closet and left there and remain mentally healthy. This, no one doubts. But we forget, it's easy to forget how dependent we are on others until they're not there, which is why grief is so powerful, the loss of a partner, or worse than that, a child. Our body doesn't have very good ways of dealing with that particular problem. And the way we do it biologically is we would fall back on this ancient molecule, which does become elevated under severe or intense stress. So the body's doing it itself. You don't necessarily have to use it as a pharmaceutical, as a drug. You can, in theory, and I think we're getting close to being able to understand this mysterious molecule well enough to use it as what I called in a paper I wrote with a series of colleagues. We called it nature's medicine. It was hundreds of millions of years ago. As vertebrates, animals with backbones came along, we needed a more complex way to manage stress. At around 600 million years ago, I know that sounds like a long time, but in evolutionary time, it's not very long. We can see in the genetics of this molecule that vasopressin, a molecule very similar to oxytocin, came on the scene. Prior to that, there had been things like vasopressin, but vasopressin was a wonderful evolutionary invention because it allowed us to tie ourselves to the stressors, to become mobilized, to get out of the way of oncoming danger, and also, as with oxytocin, to hook ourselves to others. Oxytocin and vasopressin are almost chemically identical, but oxytocin can cancel out vasopressin's effect over time. So it won't do that when the first emergency occurs, when we have what scientists would call an acute stressor. You can't stop responding if you're bleeding out, and vasopressin will prevent that. You don't want to completely shut down. In fact, you don't want to shut down at all, usually, if there's some kind of urgent demand. But what's important and what's sort of killing us as a species now is we can't stay in that alert state all the time. It's too energetically expensive. It's dangerous to the body, to the heart, to every organ. So we have to switch from threat to safety.